Hi, this is the sensor device for prevention of stovetop fires. This is a product mainly aimed at an elderly audience who is likely to forget things that they put on the stove. So basically we've got a sensor unit here that's placed above the stove that measures the temperature. We have a pager unit to be carried with the operator of the device that will update with the current temperature and alarm when a temperature that is set earlier is reached. And then we've got a relay unit which will shut off the stove if the user hasn't gotten back to the stove in a certain amount of time after the threshold temperature has been reached.
Hi, I'm Brian Widman. I was the team lead for this project, and the majority of what I dealt with was designing the cases for each unit in SolidWorks.
Hi, I'm Carey. For this project, I designed most of the power supply circuitry for the relay unit and sensor unit, and as well I designed PCB circuit boards for all three of the units.
I'm Stephen Armstrong. I'm a computer and electrical engineer, and my main work with this project was interfacing our microcontrollers with the thermopile and the transceivers to communicate wirelessly between the units and to accurately read the temperature past the control unit.
My name is Sean Kruer. I'm a computer engineer. My work was on the software for the control unit, and I also did the testing to make sure it functioned according to specifications. Now we're going to go ahead and demo our product. As you can see, when you turn the device on, you've got a temperature displayed on the screen. You can press these two buttons to either increase or decrease the temperature. Right now I'm going to set it to something that we can reasonably reach in a room, 80 degrees. Once we push this set button, we switch to a monitoring mode and we start receiving temperatures from the sensor device. As you can see, the device is updating the screen with the current temperature. If I hold my hand over the device, we break 80 degrees, the device starts beeping, we push this device to stop the beeping. Since we didn't respond fast enough, this device is going to beep and it's going to flip the relay here. As you can see, this light is not on, so this relay is open. We can close the relay by holding this button on the sensor device. The light comes back on. Now, we can also reach the stove before the relay is flipped and prevent it from ever opening. I'll go ahead and show you that right now. Get this back down to 80 degrees. Trigger the beeping. And the relay was never open.
So for component selection for this project, in the sensor device we have a Melexis 5-degree field of view thermopile. In the sensing device and the relay device we have Atmega 328 microcontrollers. The microcontroller in the control unit is an Arduino Pro Mini, and all three units have Hope RF22 transmitters.
For future work, we would like to make the buttons much larger so they're easier to press for the elderly, and we would also like to make the footprints, as far as everything else is concerned, thinner. That way that we don't have such bulky devices. Another consideration that we were thinking about was to make injection molds so that we don't have the high cost of 3D printing boxes.
Also, I'd be interested in miniaturizing the PCBs in all three of our devices, as well as using an incorporated antenna to improve the functionality and the professional look of the device.
So on the software side, future design considerations include using lower power microcontrollers, so something along the lines of PIC microcontrollers instead of the Atmegas that we were using, as well as something else on the control board rather than an Arduino, which is pretty power hungry. Also, if we could change or work on the software to make it more power efficient involving the transceivers, such as adding a standby mode, that would help the lifetime of our control unit.